Welcome to another session where we will be dealing with grade 7 mathematics, and in this session we'll be simplifying algebraic expressions using the distributive law. I'm Hiral Baljor to enjoy the lesson as I take you through the steps here. As I take you through the distributive law, I would want us to back up a little bit and explain certain parts of the algebraic expression. When we talk about an algebraic expression, we're talking about the terms, and what do we mean by an algebraic term? It's a part of that expression separated by mathematical operators, namely subtraction and addition. The variable is an unknown value represented by a letter in an expression. Another part of an algebraic expression is the coefficient. The coefficient is that number multiplied by the variable. The constant. The constant is the number value in an expression that never changes. For example, if we look at 5x minus 3, you'd have seen the coefficient of 5x is represented by 5. The variable, which is the unknown or that letter form, being x. The constant is the minus 3 value where no algebraic quantity is attached to it. In totality, 5x and minus 3 are called algebraic terms. Having known that, what is an algebraic expression? An algebraic expression, or examples of algebraic expressions, are 3x plus 5p. Note we have more than one term. One of the term being 3x, another term being 5p. Another example, 4r minus 7d, two terms, 4r minus 7d. Another example, 5 minus t. Now each of these examples have all the components we measured early on, namely the variable, the coefficient, the constant. Our fourth example, 6y minus 7. There again, variable, coefficient, constant. Another example, 5f squared plus 4. Quite different from the others where we have a square term, but that square term is represented on the algebraic term of f, the distributive law. What do we mean by the distributive law? The distributive law states that multiplying a number by a group of numbers added together is the same as doing each multiplication separately. What do we mean by that? Take an example. Look at the k here. K is multiplying a group of numbers, and that group of numbers there are the representation of those numbers, a plus b in the parentheses. Would have mean the same thing as k of a plus k of b. The distributive law here is used to expand out an expression with a common factor, and that common factor of the terms there would have been k. Another example, 3 times 2 plus 4. The common factor there is 3, which when we expand that bracket would have mean 3 times 2 plus 3 times 4. The 3 can be distributed across 2 plus 4 into 3 times 2 and 3 times 4. So when we write it algebraically, if we have a times a grouping of values, could mean distributively a times the first value plus a times the second value. We can represent that in another notation by showing you separately what exactly we mean by distributive properties there. You would have seen in each of the examples or the quadrants or the representation of the blocks here, 3 is distributed according to each section here. It's distributive across the domain, across the representations here. So distributively, 3 is going with 2 as well as 3 is going with 4. Some examples of representing the distributive law. Sometimes it is easier to break up a difficult multiplication, and that is what mathematics is all about. Making things very simple for us. Example, what is 6 times 204? 204 is quite a large number. Using the distributive property, we can break 204 into several sections that we can work with quite easily. 204 can be separated as 204. So distributively, when we're multiplying, we multiply 6 by 200 plus the 6 by the 4. So 6 by 200 would have given us 1200, and 6 by 4 gives us 24. So when we sum it, we will get 6 times 204 is equivalent to 1224. Quite easy using distributive properties. Another example, what is 16 times 6 plus 16 times 4? You would have seen in that example, there is a common factor, and that common factor is 16. Now, 16 times 6 plus 16 times 4 can be represented when we take out that factor as 16 times 6 plus 4. Remember, in mathematics, we're trying to simplify things as farthest as possible so that we'll make life easier. In computing, the bracket 6 plus 4 would have given us 10, and multiplying multiples of 10 times 16 would have given us a solution. Quite easy. Another example. We could use it for a long list of additions too. Look at this example here. 6 times 7 plus 2 times 7 plus 3 times 7 plus 5 times 7 plus 4 times 7. You would have seen the common denominator or the factor among all these terms is 7. When we take out 7, the remaining values, we can sum them. Namely, adding 6 plus 2 plus 3 plus 5 plus 4 times the common factor. When we add those terms, you would have seen that or recognize that we'll get 20 times 7. And it's quite easier then to multiply 20 by 7 rather than to multiply 6 times 7 plus 2 times 7 plus 3 times 7 plus 5 times 7 plus 4 times 7. Now, nothing is wrong with multiplying them in segments and then sum them. However, in mathematics, we are trying to be very simple, very unique, and it should follow a paradigm. So 20 by 7 will give us 140. It's the same solution if you multiply 6 times 7 plus 2 times 7 plus 3 times 7 plus 5 times 7 plus 4 times 7. Another example of using the distributive law, we can use it in subtraction too. For example, 26 times 3 minus 24 times 3. You'd have noticed there the common factor among these terms is 3. Another written form of 26 times 3 minus 24 times 3 can be 26 minus 24 times the common factor of 3. In simplifying the bracket by BODMAS, 26 minus 24 would have given us 2 times the common factor of the original terms, which would have been 3. Hence, the solution for 26 times 3 minus 24 times 3 would have been 6. Quite interesting now, yes? What we're going to move on to now are some practice exercises in which I would want to test you, put you on a challenge here using the distributive law. Let us use the distributive law to simplify 6 times 10 plus 5. Let me see your take on it. I'll give you a countdown, and you should remember when we're using the distributive law, it is the factor times the values in the parentheses. Very good. 6 times 10, the first value. Don't forget the plus sign, which is the sum of those two values, and the common factor 6 times 5. In simplifying, yes, you should have 6 times 10, which would have been 60, and 5 times 6, which would have been 30. When we sum 60, and 30, we will get 90. Another example, 4 of 12 minus 5, using the distributive law. Excellent. So you take the 4, which is the common factor, times the first value in the parentheses, not forgetting the subtraction sign, and it becomes 4 times 5. In computing, 12 times 4 would have given us 48, minus 4 times 5, which would have been 20, hence the solution would have been 28. Alternatively, because we have a parenthesis, we can go this way as well. Using the bracket, work that value out, which would have been 12 minus 5, giving us 7. And if we multiply 4 by 7, which was the common factor, the solution would have been the same. So nothing is wrong with that. I hope you have learned something where we were talking about simplifying algebraic expressions using the distributive law. I know using the distributive law, future lessons will be revolved around it. So don't give it up and use it in isolation. Do take care. I am Hiral Al-Baljur.